Hello, everybody. Welcome back. We are up to Unit 5, Lesson 3. And there are no new lesson notes for this particular lesson, so we're going to get right into the examples. A piece of meat is taken out of the freezer to thaw. The data shows its temperature M in degrees Fahrenheit, T hours after it was taken out. The graph M equals G of T, where G of T equals negative 62 times 0.85 to the power of t models the shape of the data but is in the wrong position. Jada thinks by changing the equation to j of t equals negative 62 times 0.85 to the power of t plus 75.1 makes a good model for the data. Noah thinks that n of t equals negative 62 times 0.85 to the power of t plus 1 plus 68 is better. Without graphing, describe how Jada and Noah each transformed the graph of G to make new functions to fit the data. Okay, so if we look at Jada's graph, notice Jada's graph is exactly the same as the G graph up here. Only difference is it's adding 75.1 on the outside at the end. Okay, and when it's on the outside at the end, remember, outside, that is a vertical translation or a vertical shift. In this case, it's a vertical shift up 75.1 because of the plus. So let me write that down first. So Jada is a vertical shift up 75.1. And for Noah, okay, notice Noah has the plus 68 instead of the plus 75.1. So Noah is also going to have a vertical shift up 68. However, there is also one other difference, and that is this right here. Okay, that is this thing right here, the t plus 1. Okay, so the t plus 1, that is on the inside of the function. Okay, the original function was this. The t plus 1, that is on the inside of the function. And when it's on the inside of the function, that is a horizontal shift. So in addition to a vertical shift, there's also a horizontal shift. And you might remember from the last lesson, when we do horizontal shift, everything is the opposite. So plus 1 would normally mean right 1, but the opposite of right 1 is left 1. So it's a horizontal shift left 1. So Noah has a combo shift, as I like to call it. It's a combo shift that's vertical up 68 and horizontal left 1. Okay, so that's number 1. Number 2, use technology to graph the data j and n on the same axes. Whose function do you think best fits the data? Be prepared to explain your reasoning. So to help us with that, I have a diagram here. So here's my diagram that has the original data. It has the original data, and it also has the j function and the n function. So our question is, which one, j or n, fits the data better? So to help us with this, okay, the j function is this one right here. So this is the j function. So the j function starts on the bottom and ends up top, and the n function starts up top and ends on the bottom. So let's first look at the j function. So the j function starts here, where my mouse is, and we're going to count how many points the j function touches. So it touches 1, 2, 3, and that's about it. Okay. Now let's look at the n function. The n function touches 1, 2, 3, 4, and it kind of nicks this one right here. So the n function is closer to a majority of the points than the j function. The j function really only gets these 3 right here. Okay? Whereas the n function gets a lot more of those points. Okay? So that is my opinion. Okay, notice the question asks, whose function do you think best fits the data? So this is an opinion based question. There really isn't a right or a wrong answer as long as you can explain yourself. So I'm going to say that Noah's function, the n function, best fits the data because it hits or is closer to more of the data points. Okay? So that is my reasoning. You may feel different. Just because you feel different doesn't mean you're wrong. Okay? It's all about how you explain yourself. Okay? So that is it for this particular lesson.